Dear learners, Namaste. So, in current session, we are going to understand computation of chi square. Before going ahead, I would like to introduce myself. My name is Dr. Shailendra Kumar Sharma. I am teaching as assistant professor in a government model degree college, Saharanpur, Uttar Pradesh. So, let us begin to understand the computation method of chi square. Computation of chi square as a test of goodness of fit. We will try to understand the different steps involved in computation of chi square as a test of goodness of fit, as well as chi square as a test of independence, and we will also understand its correction. So, first let us understand the formula of chi square. The formula for calculating chi square is, and this is common formula which is used across all kind of calculation of chi squares, whether it is goodness of fit or the test of independence, and the formula is chi square is sum of FO minus FE का whole square, FO minus FE whole square upon FE, where FO stands for observed frequency of a phenomenon or event which the researcher is studying, and FE stands for expected frequency of the same phenomenon based on no difference or null hypothesis. So, this is the formula we have. Through this formula we can calculate the value of chi square. So, chi square is equal to summation FO minus FE whole square upon FE. So, let us understand chi square as a test of goodness of fit. First, the chi square goodness of fit test is used to compare a randomly collected sample containing a single categorical variable to a larger population. Suppose, we may take the example, suppose a researcher is interested to understand the attitude towards entrepreneurship in rural area, and he has categorized that particular attitude in terms of three categories, like favorable, neutral or unfavorable. So, in such kind of case, we can see that there is single categorical variable. So, in such kind of cases, we may go for goodness of fit test, and this test is most commonly used to compare a random variable to the population from which it was potentially collected. Now, let us understand different steps for chi square as a test of goodness of fit. So, what are the steps for computation of chi square as a test of goodness of fit? So, these are different steps involved in computation of chi square. First is set a null hypothesis. First, we have to set a null hypothesis. Usually in any kind of statistical test, inferential statistical test, we set a kind of null hypothesis. And second step is collect the data and find out observed frequency. Third step is find out the expected frequencies by adding all the observed frequencies divided by number of categories. And after doing this, we have to go ahead towards fourth step, and this is find out the difference between observed frequencies and expected frequencies. We call it FO minus FE. And the fifth step we have is find out the square of the difference between observed and expected frequency, FO minus FE whole square. And sixth step is divide it by expected frequency, FO minus FE whole square upon FE. And the seventh step is find out the sum of these quotients. And eighth step is determine the degree of freedom and find out the critical value of chi square from table. And ninth step is compare the calculated and table value of chi square and use the following decision rule. And the decision rules are: first is accept null hypothesis if chi square is less than critical value, that is usually given in stats book. And second rule is reject the null hypothesis if calculated value of chi square is more than what is given in the table value under 0.05 and 0.01 significance level. These are two significance levels we take in psychological researches. So, let us take an example, and by going through this example, we will understand the method of computation chi square as a test of goodness of fit. So, let us first take an example. Suppose a researcher wants to measure an attitude towards entrepreneurship in rural area, as I gave this example earlier. In order to find out attitude towards entrepreneurship, researcher administered a scale of entrepreneurship on 180 rural youth. This is the size of our sample, 180 rural youth. So, what he will do for the computation of chi square as a test of goodness of fit? This is the example of chi square as a test of goodness of fit. So, for this he will proceed through different steps, as I told. The first step would be he will set a kind of null hypothesis, and null hypothesis refers to there is no significant difference. So, null hypothesis would be there would be no significant difference between the observed frequency and expected frequency. And what would be alternative hypothesis? This is denoted by H1, and this would be like there would be a significant difference between the observed and expected frequency. Now, the observed data is given in the first row of the table 1.1, and in second row is the distribution of answers to be expected on the basis of null hypothesis FA, and if each answer is selected equally. So, this is our first step, we have to set a null hypothesis. And as I said, in second step, collect the data and find out observed frequency. As I said, these are different observed frequencies. We have only single categorical variable. We remember always, as we are computing chi square as a test of goodness of fit. So, we have single categorical variable which is divided in terms of three categories: favorable, neutral, unfavorable. So, FO, that researcher has got such FOs, observed frequencies. In favorable categories, 80 frequencies are there. In neutral category, 30 frequencies are there, and in unfavorable category, 70 frequencies are there, and total would be 180. As I said, total sample size is 180. So, 80, 30 and 70. So, this would be the second step. We have to collect the data and find out observed frequency, means you have to enter different frequencies in different cells. And in third step, we have to find out the expected frequencies by adding all the observed frequencies divided by the number of categories. So, as you can see here, FO is already given and FE would be 60, 60, 60 in each category. We have divided total sample size by 3 because we have 3 categories. So, total would be 180 and in each category 60, 60 and 60 expected frequencies are we have obtained. Now, we are moving towards step 4th and this is find out the difference between observed frequencies and expected frequencies, means we have to calculate the value of FO minus FE. So, as you can see here FO minus FE is given and that is 80 in first category it would be 80 minus 60, that would be 20, and in next category 30 minus 60, that would be minus 30, and in third category 70 minus 60 and this would be 10. So, this is the value of FO minus FE. Now, next 5 and this is find out the square of the difference between observed and expected frequency. We have to do a kind of square FO minus FE square. This would be 20 into 20, this would be 400, and 30 into 30, this would be 900, and 10 into 10, that would be 100. So, this is the value of square root of FO minus FE. Now, we have to go ahead and we have to move ahead towards step 6 and this is divide it by expected frequency, and this would be 400 upon 60, as you can see here 900 upon 60 and 100 upon 60. Now, step number 7, find out the sum of these quotients. We have to find out the sum of these quotients, and what would be the value? The value would be 6.6 in first category, in second category this value would be 15, and in third category the value would be 1.67. So, what we have to do next? We have to add these all values, and this is the formula of chi square as a test of goodness of it, summation FO minus FE whole square upon FE, and if we add these total values and the value would be 23.34. Now, we have to move ahead and next step is step number 8, and at step number 8 we have to determine the degree of freedom and find out the critical value of chi square from table, and usually this table is given the end section of any statistics book, and the formula of DF in goodness of fit test is DF is equal to number of categories minus 1, and this is here number of categories are 3. So, 3 minus 1 DF would be 2. Now, at 9th step we have to compare the calculated and table value of chi square and use the following rule as I stated earlier. The rule are accept null hypothesis if chi square is less than critical value given in table, and you have to reject the null hypothesis if calculated value of chi square is more than what is given in the table under 0.05 or 0.1 significance levels. So, here critical value of chi square for DF2 at 0.05 level is, if we will refer to statistics table of chi square, the value of DF2 at 0.05 level would be 5.99. So, refer to statistical table given at the appendix of statistics book, and this would be the value of 5.99, and at 0.01 level the value would be 9.21. So, now we have to take the decision that whether we have to reject the null hypothesis or we have to accept the alternative hypothesis. In our example, we have found that the chi square value is greater than what is given in the table. So, we will reject the null hypothesis and we will accept the alternative hypothesis. So, this is the computation method of chi square as a test of goodness of it. Now, let us understand the computation method of chi-square as a test of independence. What are different steps involved in computation of chi-square as a test of independence? First, look at what is test chi-square as a test of independence. The chi-square test for independence looks for an association between two categorical variables within the same population. We remember in earlier one means goodness of it, only single categorical variable was there. In this kind of test of independence, two categorical variables are there. Unlike the goodness of it test, the test for independence does not compare a single observed variable to a theoretical population, but rather two variables within a sample set to one another. This we have to remember always, keep in mind while calculating chi-square as a test of independence. So, let us look at different steps of chi-square as a test of independence. First step is we have to formulate the null hypothesis. Second is find out the expected values by the method shown in the table. Find out the difference between observed and expected values for each cell. And the fourth step is square each difference and divide this in each cell by expected frequency, and add up these, and the sum of these values gives chi-square. So, let us first take an example. Example is 100 males and 100 females who have expressed their view on the statement. The statement is junk food should be banned, and 100 males and 100 females have expressed their views on this statement that junk food should be banned in terms of agree, neutral and disagree, and the results are shown in the table number 1.2, which is a two-way table, a kind of contingency table. And as you can see in table 1.2, frequencies of respondents in terms of views are expressed. You can see here at first column gender is there, and in next column agree, neutral, disagree. These are three categories of opinion or views of participants, and gender has two categories, males and females. So, these are the values. In males category 20 have expressed their views in terms of agree, and 30 in terms of neutral, and 50 in terms of disagree. In females categories 50 participants have expressed their views in agree category, 20 in neutral category, and 30 in disagree category, and total is 100. So, 100 females are there and 100 males are there. So, do you think that the opinion is related to the age of the participants? Let us check it. First, we have to go with step 1, and this is formulate the null hypothesis. We have to formulate the null hypothesis, and the null hypothesis is there would be no relationship between age and opinion of the participants, and alternative hypothesis is there would be a significant relationship between age and opinion of the participants. Step 2, find out the expected values by the method shown in table. So, we have to calculate the expected frequencies, and the calculating for expected frequency formula is row total into column total by number of participants. Row total into column total. This is a common formula we adopt while calculating the expected frequency in test of independence. So, here you can see in table 1.3 which is a contingency table with observed and expected frequency for data given in table 1.2. Here you can see after calculation expected frequencies are in males category, in agree category 35 after calculation, 35 in neutral category, 25 in disagree category, 40, and total is 100. In female categories, in first column means in agree column 35 expected frequency is there, in next category 25, in next and last one in disagree category 40 expected frequency have been calculated. So, total is 100. Now, come towards step number 3, and this is find out the difference between observed and expected values for each cell. We have to calculate FO minus FE, and these are the values 15, 5, 10, 15, 5 and 10. Now, in step 4, we have to square each difference and divide this in each cell by the expected frequency, and this would be the value after the division by FE. 6.4, 1, 2.5, 6.43, 1 and 2.5. Now, we have to add up means, and in step number 5 we have to add up these, and sum of these values gives chi square value, and the value would be after summation value would be 19.86. Now, we have to calculate DF degree of freedom, and the formula of degree of freedom in test of independence is R minus 1 C minus 1. Here R is 2 and column is 3. So, 2 minus 1 3 minus 1 multiplied, if we multiply it then value would be 2. So, DF would be 2. So, for DF2 the critical value at 0.05 level is 5.99 and at 0.01 level 9.21. Our obtained value of chi square is 19.86. It is far higher than the table value. So, we will reject the null hypothesis and conclude that gender is related to the opinion in terms of junk food. So, this is the calculation of chi square as a test of independence. Now, let us have a look at chi square test when table entries are small, and usually it is known as AIDS correction. When chi square is computed from table in which any experimental frequency is less than 5, then chi square is not stable. Moreover, in 2 into 2 contingency table where DF is equal to 1, there are some chances of error, and when any observed frequency is less than 5, chi square tests are biased upwards when used on 2 into 2 contingency tables. The reason is that the statistical chi square distribution is continuous and 2 into 2 contingency table is dichotomous. In other words, it is not continuous, there are two variables. In these situations, we make a correction for continuity known as AIDS correction. To apply the AIDS correction, we subtract 0.05 from the absolute value of the difference between observed and expected frequency. What is the reason for applying its correction and what is its effect upon chi square can be illustrated by an example. Example is a student is asked to respond on 10 objective type questions requiring response in yes or no. 7 times the student says yes and 3 times the student says no. In this result, is this result different from what would have been obtained by merely guessing? So, in such kind of example, such kind of cases, we may go ahead for AIDS correction, and this is the computation of chi square with AIDS correction. What we have to do is we have to subtract 0.5 value from FO minus FE, and if we do not apply the correction, then the probability of significance of chi square increase. We can conclude that failure to use the correction causes the probability of its being called significant considerably increased. So, this is all about the computation of chi square. Chi square as a test of goodness of fit, chi square as a test of independence and its correction. Thank you so much.